Noise reduction techniques. Supervised learning. Classification. Technique. Data cleaning. Description. Remove or correct erroneous or inconsistent data entries. Technique. Outlier detection. Description. Identify and remove outliers using statistical methods or clustering. Technique. Feature engineering. Description. Create new features that capture relevant information and reduce noise. Technique. Ensemble methods. Description. Combine multiple models to reduce the impact of noisy data, e.g. bagging, boosting. Technique. Regularization. Description. Add penalties to the model to prevent overfitting noisy data, e.g. L1. L2 regularization. Technique. Dimensionality reduction. Description. Reduce the number of features to eliminate noise, e.g. PCA. T-SNE. Regression. Technique. Data smoothing. Description. Apply moving averages or exponential smoothing to smooth noisy data. Technique. Outlier detection. Description. Detect and handle outliers that may distort the regression model. Technique. Regularization. Description. Use techniques like ridge or lasso regression to penalize complex models. Technique. Robust regression. Description. Employ regression methods that are less sensitive to outliers, e.g. Huber regression. Technique. Feature selection. Description. Select the most relevant features to reduce the impact of noise. Technique. Cross-validation. Description. Use cross-validation to ensure the model generalizes well and isn't overfitting noisy data. Unsupervised learning. Clustering. Technique. Data preprocessing. Description. Normalize or standardize data to reduce noise impact. Technique. Dimensionality reduction. Description. Use PCA or other methods to reduce noise by lowering dimensionality. Technique. Density-based clustering. Description. Use methods like DBSCAN that can handle noise by identifying dense regions. Technique. Distance metrics. Description. Choose appropriate distance metrics that are robust to noise, e.g. Mahalanobis distance. Dimensionality reduction. Technique. Noise filtering. Description. Apply filters to remove noise from data before dimensionality reduction. Technique. Robust PCA. Description. Use PCA variants that are less sensitive to noise and outliers. Technique. Autoencoders. Description. Employ neural networks that can learn to reduce noise during the encoding process. Reinforcement learning. Techniques. Technique. State aggregation. Description. Aggregate similar states to reduce the impact of noise. Technique. Reward shaping. Description. Modify the reward function to reduce the influence of noisy rewards. Technique. Experience replay. Description. Use experience replay to learn from a wider range of experiences. Reducing noise. Technique. Smooth policies. Description. Implement smooth policy updates to prevent overfitting to noisy data. Neural networks. Architectures. Technique. Data augmentation. Description. Apply transformations to training data to reduce overfitting to noisy data. Technique. Dropout. Description. Randomly drop neurons during training to prevent overfitting. Technique. Batch normalization. Description. Normalize inputs of each layer to reduce internal covariate shift. Technique. Weight regularization. Description. Apply L1 or L2 regularization to prevent the model from fitting noisy data. Technique. Early stopping. Description. Stop training when performance on validation data starts to degrade.